So to get started, let's first talk about what is GitHub. So GitHub is a source control management system. And what that means is it is basically version control of your code. So every time you upload code to GitHub, a new version of your code, it saves. Oh, there we go. Sorry about that. So, and I'm assuming online can see as well. They can. Okay, cool. So anytime you upload a new version of your code to GitHub, it'll save all previous versions of your code, which allows you to keep a log of everything that happens within your code base, which is very good for data security and making sure that you know who is contributing to what. So some of the advantages of GitHub is it really facilitates an open source world of programming. And it really facilitates code sharing and incentivizes cooperation and boosts trust between developers. So if a program is going to post their code online, you're probably going to be more likely to trust it because they're being very, very truthful and honest about what their program is doing. And also, the GitHub is a very user-friendly way of managing code and of being able to have version control, because Git is basically what underpins GitHub. Git is a command line versioning control system, which is kind of complicated. It's a lot of memorizing commands, and if you mess something up, it's very hard to go back and change something. So GitHub just basically provides a streamlined user interface for Git. Also, what GitHub does that Git doesn't is Git is very centered around local, or it can be. So Git is really good for working within local systems or servers that you have direct access to. Whereas with GitHub, it's a server that anyone can post their code to, and so it's very open and allows code sharing, that sort of thing. So, and as I'm talking about this, I want you to keep in mind that Git and GitHub is not the only version control system out there. These are just some of the different companies that have version control software. In order, they go GitHub, GitLab, Perforce, AWS Codes Commit, Visual Studio Team Foundation Server, and Mercurial. And each of these are fundamentally based on Git. And so understanding how GitHub works is paramount to understanding how any of these versioning control systems work, and could be very useful for you later on while you're working at a company. So now let's talk about how Git functions on your local repository. So there are 3 different sections where your code is going to be sitting when you are working with Git. There's the working directory, the staging area, and the repository. So right now we're assuming that the repository is your own local repository. So everything is just on your system. We're not even talking about GitHub yet. So the working directory is going to be any files that you're directly editing, saving over and over again. And so they can be changed constantly. They don't require you to upload them to the repository. So there's not really any history of what you're doing until you go to the staging area. And this is the in-between area of the working directory and repository. So this lets you choose specifically what files you're going to be sending to the repository. And then the repository is just a local copy of the code from GitHub. So let's talk about some terminology before going into what each of these means. So The main functions that you're going to have with Git are going to be commit, push, and pull. Commits are the way that you update changes to files in your local repository. Push refers to pushing committed changes from your repository to your server. And then pull is basically taking the files from the remote repository, the server, to your local repository. So I've got some representations to help you understand what each of these do. So for example, this is going to be how a commit works on your local system. So in your working directory, you're going to have a whole bunch of files as well as whatever's in your repository. So if you make changes to your files, they are not going to be automatically updated in the repository. What you have to do is you have to commit your changes. And that's one of the advantages of the staging area, is that you can choose only a couple of your files to upload to the repository as opposed to just saving all of your changes. So what you do with it in commit is you put a file in the staging area, it compares it with the repository, and once it sees that it's good and can actually go into the repository, then it updates the repository with the changes that you've made. Now, keep in mind that this is still just on your local system. This is where push comes into use. So this is where you're actually taking the repository on your computer and pushing it to the remote repository. So it's very simple. You make changes to your repository and you push, and it updates in the GitHub, for example. You might have seen memes like this where it says, git push. And the idea behind this is that up until you push to Git, it's still on your computer. So make sure that you upload your files in case of a fire, anything like that. So now let's talk about a pull, and it's pretty simple. It's just so for example, let's say someone pushes to the remote repository, someone in your team, and a pull is basically just going to bring a copy of that down into your repository. And so those are like the main commands that you're going to be using while working with Git. Another functionality of GitHub is branches, and this is really good with working with a team. I haven't really touched on working with teams yet, but when you're working with a group of people, having branches is a great way of keeping things organized, because it allows you to develop features, fix bugs, safely experiment with new ideas in a contained area of your repository. It allows you to isolate your code changes, which allows you to test any changes before merging it back with the main branch, which I'll talk about merging in a minute. And a good way to keep the repository organized is using branches, because it means that you're able to see, for example, when something is your main branch, and then let's say, for example, you have an issue with it, so you want to do some testing and fix a bug. So you create a new branch, do some work in it, and once you're satisfied with the changes that you made, you can merge it back with the main branch. So branches can very quickly get out of hand. For example, this might be the branches that you'd see with a robot. So you have your main branch along with some control subsystems, some controller support, autonomous drivetrain, and that's simplified. There's a lot that goes into complicated projects. So it's important that you keep your branches clean, and you make sure that you're naming them as you go, just to keep everything organized. So something else that you might have seen before are forks, and they're very similar to branches. And in the back end, they're honestly almost the same thing. The main difference is that with branches, all the work is done in one place, but you need to add all your team members beforehand to the project so that they can contribute to the project. Whereas with forks, any user can fork a project, do any changes that they want to it, and then try and create a merge request, which we will talk about in a minute, to get that into the main branch. But it does mean that collaboration is a little bit trickier, because the fork owner needs to add the person as a collaborator if they want to be able to merge that with main. So this, what I went over, kind of ignored a problem that may come up as you're using GitHub, which is a conflict. So, for example, if you make changes to your code, and while you're getting ready to push your code to the external repository, what happens if someone else has already made those changes, made some other changes, and so when you try to push, it doesn't work. In this case, what you're going to have to do is merge. So this is when you're going to be pulling information from the remote repository and merging it with your own. So this is a screenshot of what you might see. This is what you see if you're using GitHub's nice user interface. If you're working with Git, it's a little more obtuse, but this is just a very nice user interface that shows exactly what changes were made by the other person. And it says, you can see right there that you can see exactly what's changed, and you can actually choose what you want to keep, what changes you want to keep, and which ones you might feel were unnecessary or get in the way of what you're adding, and just delete those. So once you've done that, you can merge it back in with the remote repository. So now I'm going to go through the process of setting up an account and that sort of thing. So you can feel free to follow along if you don't already have a GitHub account. I'll kind of go through it quickly, and then I'll kind of go over all the different things that you can do with GitHub. I'd like to go through how you would set up a repository, how to push code to that, and that sort of thing. So as you're setting up an account, keep in mind that the username that you use is actually going to be the part of the URL that you see right there. So make sure that you choose a professional username. So from there, you'll see there's a couple of different account types that you can get. I personally just have the free account because I made my account years ago. So this was before they had the student benefits. But I mean, if you're a student, you might as well take advantage. But to be honest, there's not a huge number of differences between the two, and you'd be fine going with either. And then this is what your homepage would look like. Now I'm just going to show you a quick screenshot of what my homepage looks like. So this is just a screen grab of all of my repositories. I've got a profile picture, some information about myself, that sort of thing. So from here, I'm just going to go into a demo of GitHub. So probably should have pulled this up beforehand. Okay, so this is going to be what your main page is going to look like. So if I go to the profile, you'll see all the repositories that I've worked on, all that sort of thing. So if I go into any of these specific ones, you can see that there are a couple of files here. This is the README. It's going to be the landing page for any of your projects. So this is in Markdown syntax. So basically, it's just like a way of formatting text. So it's a good idea to, when you're uploading your projects, create a README, because then it just gives people an idea of what you did. You can add GIFs, that sort of thing. So there's a lot of things you can do to present your work. So from here, I'm just going to now go through, let's see if it worked. So one of the pieces of software that I definitely recommend using if you're working with GitHub is GitHub Desktop. It's basically a user interface for Git, and it's extremely helpful. It takes you through all the steps of setting a repository and all that sort of things, but I'm going to log in real quick, and then I'm just going to take you through the tutorial that it has. You can really do that on your own if you want, like this tutorial right here, but I just want to give you an idea to like reinforce everything that I talked about so that you know what each step is doing. So if we go to create a repository, it says it's going to be created on my local machine and pushed to my account. It'll only be visible to me. So yeah, that was when I tested this beforehand. So I'm going to see if I can delete that repository real quick. So I guess this is a good example of how to delete a repository. So if you're here, you can go to settings. Should be down at the bottom. Yeah, delete this repository. Wants you to type that out, so I'm just gonna. All right, and it was deleted. Yep. So let's try this again. So this is gonna create a repository, push it to GitHub. I have to sign in once again, but and there we go. We create a repository. So if I go to my repositories, you see it says 6 right now. Now it says 7. So here's the GitHub tutorial. This is all the information that it uploaded. It's just the README really right now. But if we go back to this, make that a bit bigger. So we can see this is my current branch main. The branches that when you create a new project, the main branch is going to be automatically named main. If you see some branches in other projects named master, that's because they recently, a couple of years ago, changed the naming scheme. So just know that that is going to be their main branch. So it's asking us to create a branch. That's as simple as going up to here, creating new branch. Let's name it new branch. And your naming shouldn't have any spaces in it. If it does have any spaces, then it says it'll be created with a hyphen. So, and now you can see my current branch is new branch. That was just created a minute ago. And if I go back to GitHub Desktop, or the web page, then we can see if I reload the page. Oh, right. So you can see that since I've created this this branch, it still only shows that there's the main branch and that's it. There's no other branches within there, and that's because I haven't actually pushed anything to GitHub yet. So if we go back to GitHub Desktop, let's do what it says. Edit the README file. Oh gosh. Hopefully this works. Don't know what this editor is, but hopefully this works. So I'm gonna write my name there, and then I'm also going to delete this line, just to kind of show you what it'll look like once you've actually uploaded it. So I'm gonna save the file, and now, oh, it created a new file. So now it shows right here. These are the changes that you've made to your folder, your repository. So you can see that I removed that line and I added this one. So now it's asking us to create a commit where you first need to write a summary. The summary is going to be, I think it's like a 256 character limit. So it's basically just a title of what you've done. So say changed some of the text. So in your description, you want to be as descriptive as possible about what you've changed, because as you'll see in a minute, once you've made changes, you have to actually okay the changes. And so the person that's going to be okaying the changes if you're working with a group, needs to understand what you've actually done, to ensure that they understand what is being changed and if there's a reason for it. So let's just say moved a line would so with that, I'm going to commit the new branch. All right, and if we go back to here, again, still no changes because we've only committed it to our local repository. So now we need to actually push those changes to the remote repository. This calls it publishing. So if I publish this branch, simple as that. There we go. Now if I go back here, there's my branch. So this lists the default branch, active branches, as well as branches that I've created. So, and if I go to the main branch, you'll see it's still what it was before. But if I go to the new branch, then here's the changes. There's my name. So you can see that there's this new pop-up here right now, where it says new branch had recent pushes less than a minute ago. So if I go back here, it's asking you to create a pull request. So what this means is this is just assurance that the person who has authority to actually change the main branch understands what is being changed within the project. So this is just to ensure that there is security within the project. So if I go to compare and pull request, then we can see change some of the text, remove the line. So we'll create the pull request. And we don't actually have to create a pull request if we're not like content with where the project is. We can continue making changes to that branch, and then finally when we're content, merge it. But we're going to create the pull request just now. And there we go. So basically what this is saying is this is just the main branch. And now we have one pull request, which is asking to set that new branch to the main one. So if we go here, we can see exactly what was changed. If we go here, so we can see this file was added because of the whatever editor I ended up using. And we have the README here, so we can see exactly what was changed, all that sort of stuff. So if we go back here, we can actually merge the pull request. So from here, it's just you can change the title, kind of add some clarification about what you're merging, that sort of thing. And once you actually merge it, it says pull request successfully merged and closed. So that means if I go back to my main branch, it was saved properly, and new branch is still there. But that's just because it's saving that history of what was actually used. So if I go to, I believe it's settings, branches. No, actually it's insights. We can see, this is a private repository, so it's not actually letting me see the network or anything. But with a, so let me just go to, So we'll go to a random repository. Sure. Okay, that's not a random. Okay, I'll go to my repositories. Let's just go to public one. And one thing I also wanted to mention was one of the advantages of using GitHub is you also get a one static website that you can use with your account. So you can see that this is my personal website. So if I go to this link right here, let's copy it. So right there, you'll see I have a personal website where I have just some information about myself. So that's one of the advantages of using GitHub is that you can actually create a website for yourself that you can stick on resumes and that sort of thing, which gives you a little more of a professional, tone. So if I go back here and then go to Insights and Network, you can see this is exactly what I've done with this website. So you can see, let me see if I can zoom in a bit. So GitHub Pages is like the repository I forked this from, and from there I've created my own changes, and you can see that like this tree can get very messy very quick, but it's a good way of keeping track of exactly what changes have been made, that sort of thing. So if I go back to GitHub Desktop, now I've finished this. So from there, I think, let's see. I think that's most of what I wanted to show you. There are some other things to keep in mind while you're working with GitHub. Like if I were to go to a project, you can see that there's this releases section right here. If you're working with some, someone that's uploaded code and you want to kind of download it and run like an exe, then the releases tab is going to have the exe, that sort of stuff. So you don't have to just download all the code and compile it yourself, because that's a waste of time. So that's pretty much all I had. If you have any questions, I'd love to hear them, and I'd be willing to answer anything you've got. So it's for anyone online that didn't hear him, he asked that GitHub is mostly for, well, I'm going to rephrase your question a little bit. And his question basically amounts to, is GitHub only public, or can I have private repositories? And the answer is yes. So with a free account, I think they changed it a couple of years back, where they now, with any account type, you can create both public and private repositories. So with the example repository that I made, if I go to my account and repositories, you can see that this repository is private. So if I were just some random user and went to my page, you'd only see the 6 public repositories that I have. So even if you're working with some code that is proprietary or something and you don't want it going out there, you do have options for keeping things private. Mm-hmm. And I think, let me show, if I go new, yeah, right here, it says you can choose between public and private. So, and there's multiple ways of creating your repository. You can either do it through the web page, or you can do it through the app. Once I actually don't know if that's possible. I have to look into that. Any other questions?
So, do you mind jumping to, now you showed us R, or you showed us your GitHub, do you mind jumping to GitHub, like sklearn, and has a really developed library, so we can see a little bit of that?
Oh, sure.
Because I know, at least from a machine learning perspective, we encounter GitHub for things like scikit-learn, which is a Python logic for machine learning techniques. So if you wouldn't mind just like jumping to that and just summarizing briefly some of the topics that you discussed in your profile as like we talked about it yesterday a little bit. Do you mind like at least showing that briefly?
Yeah, sure. So let me go to their actual repository. So yeah, sometimes it's kind of hard to find things using just the GitHub search, but using like Google, it's not too hard to find. So the mistake I just made was I searched in this topic, whereas there's like multiple ways you can search. So if I'm just searching all of GitHub, then this is like the main repository. So as you can see right here, so we have the releases right here. That's what I was talking about earlier. So with the releases, it has so different repositories do different things. This one just has its source code in a zip file and tells you how to install it through pip. So if you're curious what pip is, it's like it's not GitHub. So like if you're doing pip install or anything like that, it's not actually downloading anything through GitHub. It's an external server that has all of the different projects that you can download it through. So you're downloading it through pip directly. So let's see, that's the releases. This is all the code that you're gonna have. And when you go to the actual make files for some of these more developed projects, they're actually very helpful in showing you where exactly you need to go for information. So, for example, these up here are really only useful if you're developing scikit-learn as opposed to working with their API. So these are all very helpful as it shows like what version of Python it works with, whether or not the build is passing, sort of stuff like that. Because GitHub has a lot of, like, for example, if I go to the build passing, if I click on that link, it goes to Travis CI. And what Travis is it basically keeps track of all the different versions of libraries and stuff, and automatically alerts you if one of your libraries is out of date, or anything like that. So there's a lot of stuff within GitHub that it does automatically that is hard to like. That kind of just does, and you'll see it and then look into it and then understand it. But it's kind of hard to go over everything without going over everything. So you can see here. Oh yeah, sorry. Oh. Yes. So with bigger projects, so like this is actually like a substantial number. Most projects are not going to have this many. But you can see that there's just a whole bunch of different pull requests. So if I go into any one of these, you'll see. This is what this random person changed. They added a bunch of code. Don't know what any of that means. But if we go to the conversation, you can see that if you're making any changes to these repositories, you can actually have conversations with the main developers. And so this is like the developer trying to understand why they made the changes, and letting them know if any other changes need to be made before they can actually merge it with the main branch. And occasionally they'll say, the changes that you've made are not our vision for what we want this program to do, so we're not going to merge it. So usually you will not see this many pull requests or things like that, but it's just a matter of this is a gigantic project. So, and if one of the other tabs up here is this issues tab. So if you're using something like scikit-learn and you run into an issue, you can actually submit an issue, like a bug report. There's a whole bunch of things that you can do, which is basically just your way of saying, I have this issue. Sometimes you can kind of get into exactly like this has a form for how to actually submit a bug report. So it shows, you can see that it has, you need to be able to reproduce the error, show why it's wrong, and then also give versioning. So that's just a good way of seeing exactly, like if you're having an issue with something that is working improperly, then you can actually talk to the developers and try and get that fixed, even if you don't yourself want to develop fix the bug yourself. And with big projects like this, you can see there's a whole lot of issues, so it might be a while before they get to it, but usually they're pretty good at responding within, this was submitted an hour ago and there's already people talking about it, so usually it's pretty good at dealing with issues. But yeah, so so going back to the README, you can see that a lot of them will have different dependencies that you're going to need. Obviously, a lot of this might be handled by pip or by whatever installer you're using, but it's good to have somewhere you can go back to. And it shows you how to get the source code, how to test, that sort of thing. And then this is where it's really good. So usually on a README, they'll have documentation or links to documentation. So occasionally, you can see that there's this wiki tab right here. Occasionally, they'll have the documentation here. But with some bigger projects, they might just have a website that you can go to where they're just going to have all their documentation freely available like that, which is super useful. It's just a matter of knowing where to look for it, So this is what like a bigger repository looks like. And there's also like, if you wanted to kind of develop out your own, like kind of work on this, when it comes to working with these repositories, it's hard to actually create branches and that sort of thing just because you're not a part of the team. So what anyone can do is just hit this fork button, and what you're doing is basically creating a branch independent of the project on your account, and all it's doing is letting you work on it. And then once you're done, you can submit a pull request like this. So that's what all of these are. You can see that there were 23,000 people that forked this project. So that's substantial. All right. Any more questions? Or did I answer your question?
Yeah, we had talked about it previously, so I just wanted to make sure to circle back, because I know a lot of people who might view this video, especially from our informed after, deal with this, they go looking at machine learning and this brings up. So it helps understand how this works once they make it they can prompt requests and all that stuff. The other question I have is, I noticed some of the languages, but is this for big language, or is it, so you can do MATLAB on here, you can do Plus, Python?
So for anyone online that didn't hear it, I'm not sure how good this mic is. He was asking what languages does GitHub support? Does it support anything? And the answer basically is yes. So if we go down here, we can see exactly what languages were used in creating this project right here. So we can see that the majority of it is Python. There's some Python, C++, and some other stuff. So I'm not sure what that is, but so it does have a lot of support for the. So if I go, let's see if I can remember how to do this. Actually, let me just go back here. Here, if I click on Python, then well, actually, let me just search for Minesweeper within all of GitHub. So you can see on the left here, these are all the languages you can filter by. So these are just like some of the main languages that people have used to develop applications like this. But it's going to support most languages, to be honest. There might not be like specific, like if it's some language that barely anyone uses, then there might not be syntax highlighting and that sort of stuff for when you're actually viewing a project. But there will be like you can still view the code just fine, that sort of thing. All right. Any other questions? Any questions from online? All right. Well, thank you guys for coming out. Appreciate it.